So now that you know a little bit about gases and a little bit about equations, we're going to try to pull some more things together. Quick reminder, what is STP? That stands for standard temperature and pressure. There is a standard temperature for gases. It's 273.15 Kelvin. Standard pressure is 1.00 atms. First series of questions. If 1 mole of gas is at STP, what is the volume of that gas? Now, you've actually already answered that. We're going to solve it, but we'll refer back to where you've already answered that, and you may remember the answer already. So remember, PV equals nRT. Solve it for V. One mole, 1 times 0.0821 times temperature. So it says STP, so our temperature is 273.15, that's Kelvin, divided by our pressure. So again, part of STP is pressure, 1.00 atms. Let me make sure that I put mole. I'm going to throw my R unit in really quick. Liters, atm, mole, Kelvin. So we need to see that our Kelvin here cancels, our atm cancels, and our mole cancels. So our unit that we're left with is a liter. And I'll throw that in the calculator. 0.0821 times 273.15. 22.4, because I have 1, 2, 3 sig figs in several places. That's the volume of that gas. Now, go ahead and solve it yourself for the other two equations and pause the video while you do that. Okay, when you do the math in all three circumstances, all three of them say 1 mole. All three of them say STP, so they all three have the same pressure and temperature, and of course, since R is a constant, they have the same constant. So all of these gases, even though they're different, at a certain temperature and pressure, they have the same volume. That's the volume that they'll spread out and that they'll take up to maintain that pressure. So this is called standard molar volume. Is it only true for STP? Well, let's see. We'll take the same equation. Volume equals nRT over P. And we'll put our numbers in. So 1 mole of CO2, and then we have 0.0821. And then we have our temperature, which is 300 Kelvin, divided by pressure. Remember at STP it's, oh, it doesn't say STP, does it? This one says that it's at 2 atm. And of course that's liters, atm, moles, Kelvin. The unit's going to come out to be in liters. When we put this in our calculator, we will get 0.0821 times 300 divided by 2. So that gives us 12.3 liters. So that is not the same as this. So only at STP can you use that straight up 22.4. Let's see how they compare to each other. Now they all are 1 mole. Let's see, they all are at the same temperature. They all have the same R value, but look, they do not all three have the same ATMs. I actually am pretty sure that that first one was supposed to be a 1 right here. So this really matches with the CO2. So 22.4 is only true for the volume of 1 mole of gas at STP. Now, let's see if you weren't sure about that. We're going to go back up here and you'll see where we actually solved this earlier. right here. STP. At STP, what volume of gas does 1 mole occupy? It's right here. I already solved it. So we're going to use that information to shortcut us through some of these longer problems.